Great. So, hi, my name is Shimon. I want to go over the WekaIO file system with you. A UI demo. We'll go into the file system itself. I'll run some IOs. You'll need to forgive me if once in a while I'm switching into terminal mode to show some more stuff. So first of all, run some IOs. Let's look at the UI of the environment of the system. Okay, so what we see here is we see the storage nodes and the clients of the system. We see that the system is currently composed out of 6 storage nodes. The green squares are actually the CPU cores that each of the storage nodes are contributing to Weka, and the white rectangles are the number of SSDs that they're contributing. More servers, different servers that can be configured accordingly. If you can also zoom in per server and dive in to see the exact details of the server, IP address, Weka version, type of cores, how fast are the cores. For example, if there's a problem, of course, the relevant core would light up as failed. The devices that are being contributed, in this example, these are SSDs. By the way, this is currently all running on AWS. These are AWS instances. There are 3 extra large instances. So we're really showing you a virtualized environment as well. What you see here is actually the client. So we're showing the hyperconverged and the dedicated storage environment. As you asked, I think, before, there's actually no real difference. You can run IOs from both of them if the system is configured in that way. But what we've seen is that a lot of clients, customers, prefer to configure cluster storage and connect their existing clients for that. And of course, when you go to the clients, you can see also their client names, IPs, their details, status. You can take clients offline, add them. We'll see that in a bit. By the way, going into the Weka cluster UI, you just point your browser. You don't need to install any additional software. What more do we see here? Let me see if my IOs have started.
So Shimon, are you running an HCI kind of environment so the clients and the storage servers are running in the same EC instances? Is that what you said there?
So in this specific configuration, we have different instances for clients and different instances for the storage nodes.
It's almost like a dedicated storage server environment.
It is exactly a dedicated storage environment.
Only happens to be on AWS infrastructure.
Exactly. What I am saying also is when the need arise, you can also run IOs from your dedicated storage, if so you wish.
In fact, the 300 instance was 300 nodes running hyperconverged at that point in time. You saw that.
Exactly. Okay, moving on. What more do we see? Of course, we see the cluster status. We see that currently it was installed with a 4+2 protection stripe. We have 6 servers, so it makes sense. If we'll have time, I'll go through the installation. You'll see it's like a very menu-driven UI-based, and then there you get to choose it. As Liran mentioned, by the way, it's important to understand that currently each server is a failure domain. So even if a failure with 2 SSD fails, you'll see that you're degraded by 1 only. If you group a few of them to a failure domain, if a few of them would fail, then still it would be only -1 degradation. What more do we see here? We see the IOPS, throughput, and latency per reads and writes. And of course, as proper in a demo, my IOs don't show here. Give it another shot. If not, okay, we'll get to that in a bit. But of course, your main dashboard shows also your IOPS and throughput and latency per IO. You can see also once you're experiencing failures and rebuilds, you can see the protection status. You can see how much protected are you for your first failure, for your second failure. As Liran mentioned, when we have 2 failures in such an environment, of course, we work harder to rebuild the second failure, so you will be N+1 protected again. Of course, oh, there we go. So that was what I was referring to before. You see on the blue bar, you see the reads.
So a 6-server environment, less than 500 microsecond.
And these are
latency.
R3s with SATA. So
SATA over AWS network.
Yeah. Ouch.
Yeah, pretty decent.
Yeah, it's only FIO, but I understand.
Oh, come on. Why like this? Events, the events of the system. It's a storage solution eventually. You want to be able to give your customers the ability to track it, to manage it. So the events are actually the story of the system, components coming out, coming in, rebuild starting, rebuild completed, adding devices, removing devices, your regular events. Statistics are one of the things we like very much in our system. As Liran mentioned, we did it for a lot of time already. So we pretty much have a good grasp of what would you need in order to investigate the performance of storage systems. So just to give you some inkling, you have your statistic. You can take a look at the file system, the driver file system. You can take a look at your NFS statistics. You can take a look at your core statistic, at your raw device SSD statistics. These are the statistics that are most useful to the customers. Basically, every POSIX op that you see out there. You can take a look at your object store connectivity statistics, which we'll see in a bit. Of course, I'm going to do something, and I'm going to show you that we can even have, actually our developers are using a much more granular statistics for that as well. So very useful. And of course, no need to mention, you can take a look at the last hour, last day, last week. You can choose the date. You can add multiple statistics at the same time and view them together. And anything we can do, by the way, if I didn't mention it to begin with, everything we can do with the UI, we can do with the CLI as well. I'm just not showing it at the moment. But definitely we see customers that are scripting our statistics environment, scripting our events, using utilities such as Splunk, for example, to pull our data and monitor our environments through their other environments using our CLI and API.
You have an API that's accessible as well, or?
The API is actually public, so anything the GUI does, it uses the public API, so you could script.
OK. I'm going to jump here, for example, to show you, and then we'll go to the other tab. This is the part where we connect our Weka system to an object store. So as we mentioned, we tier eventually back down to an object store if needed. That's an optional component. It's as simple as going in, saying, is this an AWS object store or not? It's a generic object store, like a generic S3 object store that we comply with, which is basically we certified with the majority of them. Just punch in the details, configure, and you're there. I actually already configured an S3 object store with our credentials. This is one of the things that Liran mentioned. We're able to throttle the bandwidth usage because we've seen, obviously, if you have an on-prem installation and you want to throttle your connectivity to the object store according to the pipe that you have to your AWS network. And again, it's as simple as pointing to the bucket and updating it. Now going back to the why we are here, what we're doing with it is eventually to provision file systems. So file systems are contained in groups. You can either create a local group, which I did here, or you can create a tiered group. We'll go through the motion of that now. Let's call it an OBS group. It's tiered. By the way, we can configure multiple object stores that are connected to the Weka file system, and then you can have different file systems offloading to different object stores, or could be different buckets in the same object store. So when you configure a group, a tiered group, you can choose you can choose to give Weka hints about your retention requirements. So maybe I'm creating a group where I know the file systems that would be on that group would need to have access SSD latency, SSD performance for the data for 3 months. So you're actually telling Weka, hey, Weka, even though you're spanning off to the object store, we want the data on these file systems that are here for 3 months on the SSDs. So that's this hint. But maybe you're also saying, maybe after 1 month, we know that the data is less likely to be used. So you might as well spend the time tiering it in the background according to your capabilities. So that's what's going on here. The reason I'm saying hints, even though it's a policy, is because in some cases, in order to protect you, we would break that policy and we would tier to the object store. So for example, if you create a file system and you're utilizing it above a certain threshold, we would start vacating data to the object store even without its policy, so you can still retain your SSD capacity. Okay? Of course, there will be events of that, notifying that, so you'll be able to track it. And so simple as that.
So what's the demotion hit there? What does that mean? Yeah, so you had three months retention for SSD, and then
the motion hint
1 month.
is saying maybe I want the performance for these files for 3 months on SSDs, but the demotion hint is telling us maybe after 1 month I already know that I'm less likely to use it, so already copy it to the object store, but still keep it on the SSD.
Oh, okay. So during that time, it's in both places.
Exactly. It's
actually,
mostly a read cache.
It's actually less likely to modify. So if you haven't modified a file for a month, you probably won't be modifying it, because when we're pushing objects to the object storage, obviously object storage don't support modifications. So you would want to start pushing data to the object storage that you won't need to go and override, because it's a waste of resource. So you should know how long it takes for a file to be stale to actually want to be modified anymore. But it's actually not on a file granularity. We look at each 1 meg of the file independently. So one meg of the file can be consistently changing. So we won't upload it once a single meg of the file hasn't been changed for a month. If that's what you configured, we can now push it to the object storage, and now it's marked as read-only.
Super. Now, after we created a tiered group, we want to create a file system that would utilize this tier group. So for example, I already have, as you can see, a local file system called the FS1, or you cannot, but now maybe you can. It's called the FS1. That's the capacity. That capacity is carved out of the SSD capacity. I'm just going here and creating another file system. Let's call it FS2. I'm saying it's tiered. I would choose the correct group that is connected to the correct object store. And then the fun thing is I get to choose my capacity and my SSD capacity. So let's do like a 100 gigabyte file system SSD capacity, but let's do like a 2 petabyte file system. Okay, you can see these will relate to them in a bit. So basically, I just created a 2 petabyte file system, but saying I'm only using 100 gigabyte from my SSD capacity. Now, again, you'll have to forgive me because this is the part that you want to see. I can see that file system. I'm connected, by the way, to one of the clients. Maybe I can do it better. Can you see it?
Yeah.
I'm just going to mount it. Now you can see I already have my original file system, which I mounted before, of course, which is 1 gigabyte. And I have my 2 petabyte file system, which is a 2 petabyte file system. This current client is not aware where the data is residing, if it's on the SSD layer, if it's going to be on the object store layer or not. Let's fill it up with some data I have prepared in advance. Okay. So I'm now creating more data on the system. You can see, by the way, that the utilization is starting to rise. And of course, if we'll take a look at the statistics, you can see that there's orange IOs, which are write IOs. It's completed. I just created some files. Just like regular files on the file system. Now let's take a snapshot. I'm going to the file system. So snapshots. Let's create a snapshot. Snap 1. Let's give it the access point of same snap 1. This is how it would be viewed, not just its name. I want to keep it a readable snapshot. You can choose to do a read or a write snapshot. And of course, I want to take it to the current file system because the file system doesn't have any snap. So I created a snapshot. Now I'm going here. I'm going to do this. So that shows me that it shows 54. Actually, it's 50 files, right? There's some more lines over there. Now let's create more files. OK, I'm creating more files on the file system. Again, you'll be able to see the IOs. Again, stop me and ask questions if I'm just running between screens too fast. You can see that there's some more write IOs. That's it. It's completed. Let's see what did I end up with. Now I have 104 files. So that's 100 files, right? Let's take another snapshot. Snap 2.
But by the way, you can give the snapshot, you can continue a visible name that has a meaning, but then you give it the mount point name that you can actually view on a file system. So they don't have to be the same.
You could take another snap of the original snap. Is that?
I can take a snap of the snap, definitely.
Especially if it was, now that snap could have been read and write, in which case it could have been, it's independent version.
It's a different path, it's a different version, of course. Now, you saw, by the way, it's instantaneous. I have 2 snapshots. Now let's look at what it's useful. I have 104 files here, right? As they say in Hebrew, I didn't touch. And let me restore a file. Now, I want to restore the snapshot from to the current file system from when I had 50 files, right? While the file system is mounted. Of course, I know horrible stuff would happen, and I would lose my blah, blah, blah. I restored it. Now, now I have my 54
you do go for the screen, because it's...
That's the basic functionality of snapshots, just in how it works. Pretty complicated, but I think we can all manage that. The next part I think that is worthwhile seeing is the upload to object. Let's take a snapshot and upload it to our object store, because we're connected to an object store. And of course, I get information. You're about to upload data to the object store. Would you? Of course, I want to upload it. You can see the status, it's uploading. So currently what is happening is I'm uploading my data and my metadata to the object store that I'm connected to. And I get an identification, an object store locator. How is that useful? I have prepared in advance, as they say, another system. This is a second, I don't know if you can see no, it doesn't. This is a different system. You can take a look.
With 6 different EC2
6 different
storage
EC2
servers.
Exactly. For example, this is 212. And let's go to that system. I just want to prove that it's a different system. This is 73, right? So completely different. Now I want to connect it. It's connected also to the same object store, to the same bucket. OK, I know it's small, but it's the same object store, same bucket. I'll create another tiered group. Tiering from the same object store, I'll just give it some policy. And I want to add a file system tiered. Let's call it also FS2. But I want to load it from the object store. I'll also do like a 2 petabyte because that's what I wanted to do, 100 gigabyte. And I created it from the object store. That's it. At this point, I can now connect to the second demo system. I see that I have the second file system.
So in a situation where it's possible that one cluster was configured with, let's say, 4 plus 2, and the other cluster was configured with 5 plus 1, and I'm not sure if you guys even support it, whatever. And when you're taking an S3 object from one to the other, it's going to adopt whatever the protection scheme of the new
Indeed.
target cluster.
Indeed.
Okay, I got you.
Or you could have one cluster have 100 servers because need to be very high performance, but you don't want to do restores from it. So you can have just a single appliance with 6 VMs running a WekaIO cluster that could mount the same file system. And you could do restores from that Weka in a box.
By the way, this is the client on the remote system that just sees the same file because it ingested the same cloud snapshot with the meta and metadata. We just shown the data mobility between the clusters.